Hello everyone and welcome to 11th lecture of this course, which is Global Navigation Satellite Systems and Applications. And today we are going to discuss one of the very important technique with this navigation systems, which is differential global navigation satellite systems. Earlier we used to say differential GPS, but now we are having many other navigation systems. So, now we are calling as differential GNSS, in which let's understand first about the basics of this one. Basically, in differential GPS or GNSS, what we are doing, we are recording not only the signals which are being received by a receiver, but also at the same time at a permanent station or a base station, we are recording errors as well. So, and assuming that the roving station, which is in the field, and the permanent station data, they are accessing the same sets of satellites. So, if this is the situation, then from one location which is stationary, we can have the error information, and that error we can subtract from the location which we are getting through rover GPS or GNSS receiver, and then we can improve the accuracy. So, the main purpose of differential GNSS is to improve the accuracy, so that we can get much more accuracy than using a single standalone GPS. So, it is a basically differential technique to improve the performance, and differential GPS involves as just mentioned two receivers. As you can see, one is the base station and another one is the rover station, and these two receivers they will have some distance. So, the baseline is there and this is the baseline basically, and one rover station can be, or rover receiver can be taken at different locations, whereas base station is permanently located, and these two receivers will receive signals from the same set of satellites. As you can see here, the example given is only of 2 satellites, but normally you require 4 or 6 satellites to get good location. So, where the base station location is known accurately. How it is known accurately? That if you want to develop a permanent station or base station, you keep recording the data and take average location value. So, suppose a recording has been done for 24 hours or 7 days or a few months, then we assume that the average location of that place where this permanent station receiver has been kept, that is more accurate information, and this location can be used as sources of errors later on when the rover's data is available, and then these errors can be subtracted from rover's location. So, this is how this functions. So, base station is located, is known accurately. We assume that it is giving accurate information, and base station then transmits range corrections to rovers over radio link example. Now, this is optional. It is not necessary that you need to have a link between base station and rover station as shown here. Later on, through post processing also, these corrections can be done, errors can be removed, and therefore, the position can be improved. So, this is optional part, that whether in real time the location information from base station or error information from base station is transmitted to the rover. It can be done later on also, because sometimes it is not easy to transmit the data when the baseline, the distance between these two receivers is large, then it is sometimes it is not possible. So, later on through post processing differential GNSS can work, and differential position or accurate position can be achieved. So, as already discussed, that one is the stationary station, or we also call as base station in this receiver's GNSS receiver, which is acting as a stationary reference. It has a known position and transmits message for rover receiver to use to calculate its position. Its known position means if I have to do some survey in an area where I do not get any benchmark or known position. So, this base station, if I run for few days or months or hours, I can make as a that location as a known position, and that known position can be used for getting errors information for the rover station. And rover station basically will do the measurements in the field, base station will remain stationary in the area. So, base station transmits, as I have already mentioned, not necessarily all the time, it can record also, and later on it can be used to improve the position. So, let us discuss further on this aspect, that how these things work, that the basically as we are discussing, that the purpose of differential correction to improve the GNSS or position accuracy, and by which like here one example is there, that all these 4 satellites are their signals are being received by base station as well as a roving receiver, which is here it is shown through a vehicle is there. So, if all these 4 satellites are giving signals to these receivers, then the task becomes much easier and we can achieve much better accuracy. So, if a stationary GNSS receiver detects the same satellite signals, same satellite signal as rover receiver, as in this figure it is shown, it can send correction data based on its precisely surveyed location. So, this tower, which is shown as a base station, it can transmit the data as shown here as a green line. In a real time also, the position of this vehicle in which the rover receiver is installed can be achieved. So, in differential GNSS, the position of a fixed GNSS receiver is determined to a high degree of accuracy using conventional surveying techniques or taking average position of several weeks or months, or depending on how much accuracy do you want. In 24 hours sometimes it is also done, but more the data you are having, more the data is having, better the average would be, and your errors which you can use for the roving station would be much better, and your accuracy requirements will also be fulfilled. And then the base station basically determines the ranges to the GNSS satellite in a view using the code based positioning technique. This one has to remember, this is important thing here, that in differential GNSS we are using code based positioning technique. There is another technique which is called RTK, real time kinematics, in which we use carrier based positioning technique. So, we will be discussing in next lecture about that topic, but here in differential GNSS we use the code based positioning technique, and in this the location of satellite determined from precisely known orbit and ephemeris and the satellite time. And the base station compares the surveyed position to the position calculated from the satellite ranges, and differences between the positions can be attributed to satellite ephemeris and clock errors, but mostly to errors associated with atmospheric delays. And the base station sends these errors to other receivers. There may be not more than one rover receivers, which incorporates the corrections into their position calculations. If a real time differential position is required, then the signal can be sent from a permanent station or base station to the rover station. And the base station basically computes the GNSS errors, as have been mentioned earlier also, by differencing the ranges measured from the above methods. This is important that these errors are used, assuming that if I am having an average position and I get the current position, then I can compare with the average position, and that average position minus current position I get the error, and that error is transmitted to rover station, or through post processing I can improve my position accuracy of roving receivers. So, base station sends these computed errors as correction to rovers, which will incorporate the corrections into their position calculations. A data link between the base and rover stations is required if corrections need to be applied in real time. Sometimes it is not required at all. So, later on it can be done, and at least 4 GNSS satellites in view at both stations and rovers. So, that is why sometimes the baseline or the different distance between this stationary base station and a roving station is kept in a manner that they are not very far apart, and therefore, these will have access to the same set of satellites. And if this is the scenario, if this happens, then we get better accuracy. But if the base station and roving stations are accessing different sets of satellites, then our position accuracy through this differential technique may not be at a desired level. So, for corrections to be applied to roving stations data, the base and rover must be tracking a minimum of 4 common GNSS satellites. That is, however, it is always expected that more number of satellites, if they are there, and common satellites. This is important, common satellites, that the same set of satellites that rover and base are accessing. And there is a term which we used in GNSS parlance, that is the absolute accuracy of rover's computed position, which will depend on the absolute accuracy of the base station position. And what is absolute accuracy in this domain, that is in GNSS positioning? The absolute accuracy is the degree to which the position of an object on a map confers its correct location on the earth and according to accepted coordinate system. Because if I determine position of a location even from DGNSS, then how to confirm or how to mention that this is accurate position, because I have to have some comparison with that. So, that is why it is written here that according to an accepted coordinate system, that whatever the coordinate system which I am using, if my accuracy estimates are as per my requirements, then I may call as a absolute accuracy. So, in GNSS positioning, we will relook this statement, that the absolute accuracy is the degree to which the position of an object on a map conforms to its correct location on the earth, and that too according to an accepted coordinate system. So, if this happens, then we can call as absolute accuracy. Normally, using a single receiver without differential technique, we do not get as accurate position as in case of differential. So, if I give some values, then in single handheld receivers or even through smart mobile receiver, the maximum accuracy generally we get of 3 meter. But if we bring the differential technique or RTK, which we are going to discuss next, then our accuracy can be improved to centimeter, even sometimes to millimeter. So, that is the major difference between a normal GPS or GNSS operation and differential GNSS operation. Now, in GNSS, differential GNSS, it is assumed that the propagation paths from the satellite to base and rover stations are similar. As we have been discussing, that both receivers, base and rover, should receive signals from the same set of satellites. However, it is further assumed that the propagation path, that means the signals which are coming from these satellites, set of satellites to these two receivers, base and rover, they are following the signals is going through the same propagation path. If this is different, then it will affect our accuracy estimation or location estimation. So, are similar, that it is assumed that the propagation paths from satellite to the rover and base stations are similar, as long as the baseline length is not too long. Because as also mentioned earlier, that if the distance between base station and rover station is too large, then it is highly likely that we may not be accessing signals from the same set of satellites. And therefore, this propagation path for these two receivers from these satellites is also going to be different. And if it is the scenario, then we will have less accuracy. So, the baseline, if we would like to define here that the baseline, the line between a pair of stations, maybe base and rovers, for which a simultaneous GNSS data has been collected. So, differential GPS or GNSS can work very well with baseline length up to a tens of kilometers. But it is not that in few meters only, but if they are far apart of 10 kilometer, 20 kilometer, still we can work and use this technique, that is differential GNSS. And GNSS satellites orbit high above the earth, as we know. The propagation path from the satellite to the base stations and rovers pass through similar atmospheric conditions, as long as the base stations and rovers are not too far apart. And differential GNSS works very well with base stations to rover separations of up to tens of kilometers. So, if we go for 200 kilometer baseline, then definitely we might be introducing some problem about propagation path and not accessing the signals from the same set of satellite, and then problems will come. But if baseline distance is 20, 30, 40 kilometers, hopefully one should not get any such problem. For example, in differential GPS, a way to correct various inaccuracies in GPS system and hence improving the accuracy is, as here shown also, that this is the base station, this is the remote or roving stations. You are having a direct data link and transmission and receiver here, and same data from same sets of satellite is being accessed. And if this is the scenario, it works very well. Now, because there are two ways of accessing signals or calculating the position. One is the code based, another one is the carrier based. So, we will be also looking in detail about the carrier based system, that is RTK real time later in. So, the idea behind all differential position is to correct bias errors at one location with measured bias errors at a known position. So, measured bias errors, what we are doing is from the base station and errors at one location from, that is, rover station. And the stationary receiver is the key. If we do not have that benchmark base station, then of course the error information will not be available to us, and then differential GPS or GNSS technique will not work. So, the key is to have a base station or a stationary receiver, because it ties all the satellite measurement into a local reference, and then GPS or GNSS receivers use timing signals from at least 4 satellites to establish a position, and each of those timing signal is going to have some errors or delays. And the one receiver measures the timing errors and then provide correction information to the other. So, the timing errors is being measured or recorded by the base station, and whereas it provides the correction information to the other receivers, that is roving in the field. And this way virtually all errors can be eliminated from the systems, assuming, again I am repeating, assuming that both base station receiver and rover receivers, they are accessing signals from the same set of satellites, one, and the propagation path is also same. If this is the thing, then this way virtually all errors can be eliminated and we may get accuracy of millimeter range. So, this idea is very simple, but put the reference receiver on a point that has been very accurately surveyed, or it can be developed, a base station location can be developed after recording for a week or month, and this reference station receives the same GPS signals as roving, but instead of working like a normal GPS receiver, it solves the equation backwards. So, likewise we get the accurate position through differential. So, instead of using timing signals to calculate this position, it uses its known position to calculate timing, and that is why it is mentioned that is a reverse process. So, it calculates the position to calculate the timing, and this way we collect the error information, that error being those errors being received by our rover receiver. And once these errors information is available, we can subtract these errors from rover's position and can get accurate position. So, it figures out that what travel time of GPS signals or GNSS signals should be and compares it with what they are actually, and the difference is an error correction factor. And this receiver then transmits this error information or may record for post processing to the roving receiver, so that it can use to correct its measurements. Since the reference receiver has no way of knowing which of the many available satellites a roving receiver might be using to calculate its position, the reference receiver quickly runs through all the visible satellites and compute each for their errors. So, sometimes it is how to assume, how to assess that both receivers are receiving signals from same satellite. So, instead a base station or a stationary receiver go through that signals or errors data or this backward calculation of timing for all visible satellites to the base station. And so that you are having data from various satellites, your roving receiver may not be having signals from the same set of satellites. But if I am having signals from base station from 10 satellites, and there I am having from 5 satellites, at least it is expected that those 5 satellites are must be common among these 10, and that way things can be improved further. And once this information is there, then it includes this information to a standard format and transmit it to the roving receiver in real time. And this is how this is shown here. This is a complete setup of a differential GPS station, and you can also see a transmitter is shown here. This is the receiver, and these are the all controls are there. And once it is as if the reference receiver is saying that, for example, okay everybody, right now the signal from satellite number 1 is 10 nanoseconds delayed, satellite 2 is 3 nanoseconds delayed, satellite 3 or 2 is 3 is 16 nanosecond delayed, and so on and so forth. So, this information is going to the roving receivers, and roving receivers then correct its position. So, you get very accurate position. So, roving receivers get the complete list of errors and apply the corrections for the particular satellites they are using. As mentioned earlier, that the base station might be giving this information of 10 satellites, but the roving receiver is getting access to only 5 satellites, but these are the common 5 satellites, and that way it can improve the accuracy. So, it brings to end of this discussion on differential GNSS. As discussed in this topic, that you require basically 2 receivers. Probably sometime people use the identical receivers from the same company, same brand, same setup, so that any other problem will not come during such investigations or surveys or recordings. Base station ultimately records the errors, and your roving stations collects the data, but which is having errors. So, these errors which base station has recorded can be subtracted from roving stations, and better accuracy of positions or better position accuracy can be achieved using this differential GNSS technique. Thank you very much.